not up. Alright guys, so I just wanted to review everything we've learned so far with radicals because we've learned a lot. Just quick review, you don't have to take notes during this part, just look with me. So the first thing we learned was how to simplify radical expressions. So we learned that if, for example, if we have the cube root of 27x cubed y to the 7th, we can break down 27, pull out groups of 3 everywhere else, including the 27. So I broke down 27 as 9 times 3, broke down 9 as 3 times 3, pulling out groups of 3 since it's a cube root. And then we have 3 x's, so we'll pull out an x for those 3 x's. We'll pull out a 3 for those 3 3's. We have 2 groups of 3's when it comes to our y's, so we'll have a y squared on the outside here. And then left inside is a y. That's the only thing left inside. So we could have done it the long way, the kind of the caveman style way, which is fine. If on the test you had to do it this way, you put in a little extra work rather than doing it the quick way, but some of you don't understand the quick way. So you have to do it the long way, and that's okay. All right. We've also learned how to multiply radicals. So we learned if you have the same root, you can put them under the same root, and you can multiply them together. So if we have the square root of 2xy squared times the square root of 6xy, since they're both square roots, we can multiply them and put them under the same house. So I didn't multiply 2 to 6, I just left it like that so I could know the factors. So 2 times 6 times x squared. Now the reason I had x squared was an x times x. So I have x squared. And the reason I had y cubed is we had a y squared and a y. And then I did it in this problem, just example real quick. I did it the quick way. So with our numbers, we have to break them down like normal. So 2 is 2. And then 6 breaks down into 2 and 3, pulling out groups of 2. So we'll be pulling out a 2, and then left under the houses of 3. Then I did it the quick way. I said, how can we break x squared into groups of 2? I took my power 2 and divided it by 2 since it was a square root. And I get 1, so we'll pull out x to the first. No remaining. Now y cubed, I did 3 divided by 2. It only goes to 2 at once evenly, right? So then 2 times 1, so we'll pull out a y to the first, sorry. And then 2 times 1 is what? What's 2 times 1? 2. So how do we get back to 3? How many more? 1. So we have 1 remaining. So underneath was a 3 left under the house and a y to the first left under the house. Then we learned how to divide roots. So I did this one just by rationalizing the denominator. So I have the square root of 2 over the square root of 3x. The problem is the root in the denominator, the bottom of our fraction. So I took it and multiplied both the top and bottom by the square root of 3x because I need 2 of them. So I already have 1 3, so I multiplied by 1 more 3. I already had 1x, so I multiplied by 1 more x. I did that to the top and the bottom. So on top, you multiply straight across, and I have the square root of 6x squared. And on bottom, I have 3x. Then I broke down the top. I know that we can pull out x, the square root of x squared. We pull out an x. Left underneath was the square root of 6. And then on bottom, after I rationalized the denominator, I had a 3 and an x. Then I looked at this answer and said I have an x over an x. So those divided out, and it left with the square root of 6 over 3. So we've learned how to do that as well. And then we've learned how to add and subtract radicals. So the square root of 2 plus 3 square roots of 2 is 4 square roots of 2. Now remember, to be able to add or subtract radicals, you have to have the same root, and what's underneath the root has to be the same. So these were like radicals. So 1 square root of 2 plus 3 square roots of 2 was 4 square roots of 2. Okay, and then subtracting. We have 3 square roots of 2 minus 5 square roots of 8. Now remember the wolf in sheep's clothing. If we just looked at this and said, well, we can't subtract them because we don't have the same thing under the root, you would be incorrect because you've got to have the most simplified root. So we broke down 8 into 4 times 2. 4 breaks down into 2 and 2. We pull out groups of 2. So we pull out a 2 for those 2 2's. Now this negative 5 is already on the outside, so negative 5 times 2 is negative 10. So we have negative 10 square roots of 2. Now if you look here, you can tell, yes, we can subtract these things because they are like radicals. Square root of 2, square root of 2. So 3 square roots of 2 minus 10 square roots of 2 is negative 7 square roots of 2. Does everybody remember everything we've learned with radicals now? Hopefully that was just a good recap. Okay. All right. So now today we're going to be multiplying radicals that are binomial in form. So a little bit different. So we have multiplied radicals, but today we're going to be multiplying radicals that are binomial in form. So we'll finish up the worksheet 2-10. So remember, binomial means has 2 terms. So here are just some examples of binomials. 3x plus x, before we add them together, it has 2 terms. Terms are separated by plus or minus signs, so this is a binomial. This is another example of a binomial. 3x squared minus 2x. There's two terms there. Binomial. Now, we have 2x minus 5 also has two terms. That's a binomial. So this is an example of a binomial, but with radicals. The square root of 7 minus the square root of 2. Can we combine those two things? Are they like radicals? No, so we can't. And we would make sure that these don't break down, and they don't. So this is an example of a radical that's binomial in form. There's two terms there. Does everybody see how these are binomial in form? Okay, awesome. Okay, so when multiplying radicals that are binomial in form, you're going to have to distribute. So we've been distributing when multiplying two binomials in the past, but we're usually going to have to double distribute. So we know how to draw our little rainbow thing, and we'll practice that in a minute. And then after you've multiplied by distributing, you'll combine like radicals, and you'll make sure that they're in the most simplified form. Because we know that we don't know if they're like radicals until it's in the most simplified form. So we're going to be doing pretty much everything we've learned today all in one kind of problem. Okay, because we're going to have to multiply and add. So that's why I went through the review on what we've learned so far. Okay, so we're going to do problem number 19 together. So we have 1 minus the square root of 5 times 2 minus the square root of 5. Now notice, on the test, it's not going to tell you how to do it. You're going to have to look at the problem and say, I know how to do this. Now notice something. We have 1, 2 terms. That's a binomial multiplied to a 1, 2 terms. A binomial multiplied to a binomial. But we're dealing with radicals. So with these, just like if we had 2x minus 1, for example, times x plus 2, we would double distribute. So we're going to draw our little arrows. Now, it does not hurt anybody to draw these little arrows in. I have a math degree, and I still draw in the arrows, so you should probably do it. It really helps prevent errors. So what you're going to do is say, I'm multiplying all this stuff to all this stuff. So let's look at it in pieces. I'm going to look at my first term, 1, and I'm going to distribute it through to each term over here on the right. So draw your arrow so you don't miss anything. So 1 times 2 is? 2, good. And then 1 times negative square roots of 5. Good, negative square roots of 5. Okay, I'm going to pause. Any questions on that piece? Okay. All right, let's do the bottom part. So we multiplied 1 through to each term. Now we have to multiply this negative square roots of 5 through to each term as well. So negative square roots of 5 times 2. Do we put the 2 under the root? No, right? But we can say this is negative 2 square roots of 5. That's the same thing as negative 2 times the square root of 5. Does everybody see how I got negative 2 square roots of 5? Or any questions? Do I need to clarify further? Okay, so then also negative square roots of 5 times negative square roots of 5. Are they both under a root? The same root, yes. So we can put them under the same root. So we have a negative times a negative, which is positive. So we're going to have plus the square root of 5 times 5, which is 25. So everybody see how, for that last piece, negative square roots of 5 times negative square roots of 5 is positive square roots of 25. Okay, so then from here, before I do anything, before I combine any like terms, I look and see if there's any radicals I need to simplify. So we have our 2, our negative square roots of 5. 5 doesn't break down any further. Negative 2 square roots of 5 doesn't break down any further. But what is the square root of 25? 5. So really we have plus 5 here instead of this 25. And now from here, you're just going to combine like terms. So we have 2 plus 5, which is, so 2 plus 5, and that is 7. Very good. Just combine those two. Now, are these like terms? Minus square roots of 5, minus 2 square roots of 5. Yes, so how many square roots of 5 do we have? Negative 3 square roots of 5. This is like having a negative 1 square roots of 5. Minus 2 square roots of 5 would be negative 3 square roots of 5. Then from here, we can't combine these. They're not like terms, so this would be our answer. Okay, do you have questions on that? So we're combining the terms, good question. So we have the negative 1 square roots of 5 and then minus 2 more square roots of 5. So negative 1 square roots of 5 minus 2 square roots of 5 would be negative 3 square roots of 5. Good question. Right, so if there's nothing in front, it always goes without being said there is a 1 there, right? So you could throw that in to kind of help you see it better. Good question. Any others? Yeah. Yes, good question. So you mean the square root of 5? Oh, this plus 5. Yeah, good question. So do you understand how we got the square root of 25? Okay, so we have the square root of 25, and if you did that on in your calculator, the square root of 25, it is 5. It's equal to 5. So that's a good question. So we don't have this anymore. We rewrote it. The square root of 25 is equal to 5. Does that make sense? Great question. Glad you asked. Okay, any others? Okay, we're going to do another one. So let's do another one together. Problem number 24. So we have 2 square roots of 3 minus 3 square roots of 2, all squared. Now, because of that subtraction sign, it is breaking the forbidden rule to just square this and to just square this. That is like a huge no-no in math. If there was not a subtraction sign there, though, if there wasn't an addition sign or a subtraction sign, we'd just be dealing with properties of exponents. Because of the subtraction sign, we're not, though. We have to rewrite this. So once again, that worksheet is so crammed. I'm going to try to do better in the future to spread them out. You need to do these on a separate sheet of paper. I cannot help you when I can't see your work. Okay, so I would rewrite this. You have to rewrite this as 2 square roots of 3. So 2 square roots of 3 minus 3 square roots of 2 times the same thing, because that's what anything squared means. It multiplied by itself twice. So that's the same thing as 2 square roots of 3 minus 3 square roots of 2 times 2 square roots of 3 minus 3 square roots of 2. Does everybody see how I just rewrote it? Okay, now we'll just, from here, double distribute. So from here, I'm going to focus on this front term, and I'm going to multiply it through to all this stuff over here, drawing my arrows. So 2 square roots of 3, now this one's a little bit trickier. So 2 square roots of 3 times 2 square roots of 3. We have a 2 and a 2 on the outside. So what's 2 times 2? So we're going to have a 4. And then underneath, we have the square root of 3 times the square root of 3, which is the square root of 9. So we have 4 times the square root of 9. I'm going to pause because some of these are difficult. Did that make sense, that piece? Okay. Now we'll distribute that 2 square roots of 3 through to the second term. So I draw my arrows. So now on the outside, we have a 2 and a negative 3. So what's 2 times negative 3?
6. Negative 6.
Good, negative 6, very good. And then underneath the root, we have a square root of 3 times the square root of 2. Good, square roots of 6. Now I'm going to pause again. Do we have questions on where I got negative 6 square roots of 6? Okay, now we'll distribute this, I'm going to change colors, this negative 3 square roots of 2 through to these two terms, drawing my arrows underneath. Negative 3 square roots of 2 times 2 square roots of 3. Multiply what's on the outside. Negative 3 times 2. Negative 6. Make sure your signs are correct. It really changes the whole problem. And then we have square root of 2 times the square root of 3, which is the square root of 6. Questions on that? Okay, then we'll multiply that through to this nth term here. So on the outside, carefully with your signs. Negative 3 times negative 3. Positive 9, so plus 9 because it's positive, and then the square root of 2 times the square root of 2 is the square root of 4. What was that? And,
Safe haven.
oh, the safe haven. No, this one's not factoring, so there's not a safe haven. No, that wasn't a stupid question. It was a good one. But with this one, since we're not factoring, we're doing the opposite of factoring. We're multiplying out. We won't have a safe haven. Yeah, good question. All right, now from here, look at your radicals and see if any of them simplify. What is the square root of 9? 3. So we have 4 times the square root of 9. Carefully listen, everybody. So what we have here is the same thing as 4 times 3. Once again, because the square root of 9 is equal to 3. So we have 4 times 3. Does everybody see that? Which is what? 12. Okay, very good. Now, so this piece right here became 12. Now, looking over here, the square root of 6 doesn't simplify, the square root of 6 doesn't simplify, but does the square root of 4 simplify?
Yes.
It is what?
2.
So, well, yes, good. This is really 2. Now, don't make the mistake of adding. This was 9 times by the square root of 4, which is 2. So we have 9 times 2, because this whole thing becomes 2. So 9 times 2 is 18. Question on how I simplified to there. Okay. Then from there, combine like terms. So we have our 12, and our 18, and they were both positive, right? So 12 plus 18. 20, good. So 12 plus 18 is 20. 30. 12 plus 18 is 30. Very good. So we have our 30 here. We just added up those two things. And then we have, carefully here, negative square roots of 6 minus 6 more square roots of 6. How many square roots of 6 do we have? Very good. Negative 12 square roots of 6. We can't combine these two things. They're not like terms. Okay, questions on that? As you can see, it's not necessarily hard. There is a lot of room for error. You have to be really careful. Okay, so if you'd like, I can do one more. I can do number 25 with you, but if you'd rather, I'll just let you work by yourself. How many of you would like one more example? Okay, that's plenty of people. Okay, so let's do number 25. So we have 4 minus the square root of 3 times 2 plus the square root of 3. Now, once again, guys, you have to know that looking at this, we have a radical here, a radical expression here, and a radical thing here, and it's binomial in form. 2 terms, 2 terms. So when you see this on the test, you know I've got to double distribute. So let's focus on 4 and distribute that through to both terms over here. 4 times 2 is 8. And then 4 times the square root of 3. We don't put what's under a root with something that's not, so that's just going to be positive 4 times the square root of 3. Yes, good, good. Okay, questions on that? Now we've got to distribute this negative square root of 3 through to each term, so negative square root of 3 times 2. Now once again, 2 is not under the root, so don't put it under the root with something that's not. Negative 2 square roots of 3. Very good. And then we have negative square roots of 3 times positive square roots of 3. So that's going to be negative square root of 3 times 3 is 9. So then from here, you'll check all your radicals and see if any of them simplify. The square root of 3 doesn't simplify. The square root of 3 doesn't simplify. But the square root of 9 is equal to 3. So this becomes 3. So what we really have here is minus 3, because it was minus the square root of 9. The square root of 9 is equal to 3, so that's minus 3. So then from here, we'll combine like terms. So you'll do 8 minus 3, which is 5. And then 4 square roots of 3 minus 2 square roots of 3 is, good, positive 2 square roots of 3. So that'll be plus 2 square roots of 3. Okay. So you'll distribute, simplify your radicals, combine like terms. Okay, so now practice that for a second. Do problems 19 through 27. We just did a few of those together. I'll check them, and then we'll move on. We'll continue on this worksheet. Once again, I would really pay attention to this part of the lesson, and then you can go back and work on the worksheet. You get into trouble when you guys just keep working on the worksheet and not listening to my lesson. Okay? Okay, so now we're going to talk about when multiplying with conjugates. Okay, now remember, we have to know what a conjugate is before we can actually multiply it by one. Okay, so a conjugate, it has the exact same terms, just to change your sign in between the terms. We've seen conjugates before. So once again, I'm going to say that again. Conjugates will have the exact same terms, just to change your sign in between the terms, in between only. So look up here. These are some examples of some conjugates. 1 minus the square root of 5 and 1 plus the square root of 5. These are conjugates because of the minus sign and plus sign. Does everybody understand that? The change your sign only in between. Does everybody see how it's a 1 and a 5? 1 and 5, the only change is the sign in between. These are conjugates. Look up here. Right here, this is another example of conjugates. Negative 1 square root of 3, negative 1 square root of 3. The only difference is the change of sign in between. Does everybody understand that? And then looking right here, these are examples of conjugates. The square root of 7, the square root of 2. The square root of 7, the square root of 2. The only difference is the change of sign in between the two terms. Does everybody get that? You all know what a conjugate is. Okay. Awesome. Okay, now the cool thing is, when multiplying by conjugates, your middle term will always add up to be 0. I'm going to say that again. When multiplying with conjugates, your middle terms will always add up to be 0. Those middle terms will always cancel out. But you have to understand something. This is only true with conjugates. Otherwise, your middle term will not go away. Okay? So I'm going to do it the quick way. I'm not even going to multiply my middle terms together because they're going to cancel out. But if you get in the habit of doing that, you're going to get them wrong. You can only multiply the two end things when you're dealing with something that's a conjugate. So we're going to do an example together. So number 28. So if you read the instructions, it says multiply each pair of conjugates. So now I'm going to do this one the long way, multiply everything out so to show you that the middle term will cancel out. Then from then on out, if it's a conjugate, I'm not going to take the time to multiply the middle terms together because that's just extra work. So looking at this one, we've seen stuff like this. We're just going to multiply them out. So we do 3 square roots of 2 times 3 square roots of 2, which is 9 square roots of 4. Very good. Then 3 square roots of 2 times positive 9 will be good. 9 times 3 is 27. So we have 27 square roots of 2. Questions on how I got 27 square roots of 2? Now we'll multiply this term through to each term over here on the right. Negative 9 times 3 square roots of 2. Negative 27 square roots of 2. Questions on that? And then we do negative 9 times positive 9. Negative 81. Good. So then from here, guys, we're just doing the same thing that we just did. I'm just going to combine my terms. So first of all, we've got to simplify our roots. This is 9 times the square root of 4, which is 2. It's not 9 plus 2, is it? Was there a plus sign in there? No, so we're multiplying. What's 9 times 2? So we have 18. This became 18. And then right here, so we have 18 and then minus 81. So let's combine those. What's 18 minus 81? Good, negative 63. So I just combined my numbers. I combined positive 18 with negative 81. Those are gone. Now what? Look right here. With our middle terms, positive 27 square roots of 2 minus 27 square roots of 2. What happens? Those add up to be 0. Our middle terms canceled out. So our final answer is negative 63. Did everybody see how the middle terms canceled out? Now I'm going to say that again. With conjugates, everybody listen. With conjugates, your middle term will always cancel out. Okay? So why take the time to bother to multiply the middle terms together? But the only problem is people at your guys' level seem to, after you start practicing conjugates, you start to do things that are not conjugates this way, and it would be incorrect. So let's do problem number 30. So looking at problem number 30, now on the test, I'm not going to say these are conjugates. You're going to have to recognize that they're conjugates, okay? Are these conjugates?
Yes.
Yes, because of the change of sign in between only, right?
Yes.
Right? Okay. So we have the exact terms, just a change of sign in between. If it was the same sign, are they conjugates? No, right? We have to double distribute. So we know the middle term is going to always cancel out, guys. So I'm not going to multiply the middle terms out. If you want to, you can. The middle terms will cancel out, though. So I'm going to do the front term with the front term. So 5 square roots of 3 times 5 square roots of 3. What's 5 times 5? 25, and then the square root of 9, right? 3. The square root of 3 times the square root of 3 is the square root of 9. Now, guys, the middle terms would be, if I was to distribute that through to here, I'm not going to multiply the middle terms through. I'm going to multiply my two end terms because I know the middle terms cancel out. So now I'm going to take positive square roots of 2 and multiply it to negative square roots of 2. So we'll have negative square roots of what? 4. Now, did everybody see how I skipped the middle terms?
Yeah, why did you do that?
Because they'll cancel out. Because the conjugates, we know that those middle terms will cancel out. So we wouldn't have been incorrect if we would have multiplied them. It's just they're going to cancel out. Does that make sense?
So it's just a waste of time.
It's just a waste of time, kind of. Yeah. Now, let's simplify this. So we have 25 times what? Square root of minus 3. So 25 times 3 minus what's the square root of 4? 2. So now you'll do it in your calculator. 25 times 3, which is 75 minus 2, 73. Very good. Our answer is 73. Now, everybody listen. This is so important. People get into bad habits. And they start to only multiply the front term to the back term to the back term when they're not dealing with conjugates. You will get the incorrect answer if you do that. So if this is going to make you have bad habits, don't skip any steps. Just double distribute, combine like terms. Do you all understand that on the test, if you multiply only the front and back of something that's not a conjugate, you would be getting it wrong. The only reason we're skipping that step is because we know because of conjugates, the middle term cancels out. Do I need to do another one?
Sure.
Doesn't look like it. Everybody looks like they're ready to work. So 28 through 33, go. Okay. So now that we've learned conjugates, the whole reason that we've learned how to multiply conjugates is for a reason, okay? So we've learned how to multiply conjugates for a reason. For this reason, we're going to have sometimes denominators in the bottom of our fraction, where we're going to have the bottom in the form of two binomials. To get rid of it, to get rid of our roots, we've got to multiply by the conjugate. Did you notice? Look at your problems 28 through 33. In any of your answers, did it come out with a root? No. So the conjugate fixes the roots, okay? But, so looking at, for example, number 34, we have 3 minus the square root of 10 over the square root of 5 minus the square root of 2. We have to rationalize this denominator. But until today, we would not have known how to do this. But today, now that we've learned, we know how to do this. We've got to multiply by the conjugate of the bottom so that we can have our roots go away. So I'm going to multiply the bottom by the square root of 5 plus, since that's opposite of minus, plus the square root of 2. If you do that to the bottom, though, you have to do it to the top. So the square root of 5 plus the square root of 2. Now remember, the reason we can do this, you guys, is because that's a fancy one, a very fancy one. Is everybody okay with this up to here? Now, you have to be very careful because if you multiply by the same sign, that's not a conjugate, the middle terms won't cancel out. All right, so let's put parentheses around all this stuff and then distribute. Now, on top, guys, we cannot just multiply the front term and the back term. That would be incorrect. The top part is not conjugates. So these problems are pretty involved because you're going to have to multiply this out by double distributing. So I'm going to do that. 3 times the square root of 5 is 3 square roots of 5. I'm just focusing on the top. 3 times positive square roots of 2 is positive 3 square roots of 2. Questions up to there? So then I'm going to have negative 10, negative square roots of 10 times square roots of 5. So we'll have negative square roots of 50. And then negative square roots of 10 times positive square roots of 2. That will be negative square roots of 20. The top is very involved, okay? So now we're going to break this down and simplify. I look at all my roots. I'm going to simplify. These roots don't simplify any further, but the square root of 50 does. That breaks down into 5 times 10. 10 breaks down into 5 times 2. Then pulling out groups of 2. So there's 2 5s right there I can pull out. So I'm going to have minus 5 square roots of 2. So everybody see how this is a very involved problem? It's like we're not even close to being done. Is everybody following me? Okay. Now I've got to simplify the square root of 20. 20 breaks down to 2 times 10. 10 breaks down into 2 times 5. Pulling out groups of 2. So we have 2 2s right there we can pull out. The 5's got to stay. So we're going to have minus 2 square roots of 5. So does everybody see how I just simplified this piece and this piece? Then from here, we'll combine like terms. So from here, we'll combine like terms. We have 3 square roots of 5, any other square roots of 5. 2 square roots of 5. 3 minus 2 square roots of 5 is 1 square roots of 5. So I just am combining like terms. I combined that with that because they're both square roots of 5. And then 3 square roots of 2 minus 5 square roots of 2 is negative 2 square roots of 2. So I just combined these two things. That was just the top. Now on bottom, if we think back, we were here. I'm going to multiply that out. Now these are conjugates, so I'm only going to multiply the front and the back, but I got to be careful. A lot of you are forgetting that you have to multiply the front with the front, the back with the back. So the square root of 5 times the square root of 5 is the square root of 25, right? And then negative square roots of 2 times positive square roots of 2 is negative square roots of 4, right? So then we have the square root of 25 is 5. The square root of 4 is 2. So we have 5 minus 2, which is 3. So on bottom, we have a 3. Then you'll look. Do all three things on the outside of the root simplify. 1, 3, 2. They don't simplify any further. If they did, we would divide things out, but they don't. So this is our final answer. Does everybody get that? That was a very involved problem. It basically takes everything we've learned about radicals in one problem to know how to do this problem. Okay? So on number 35, what's the conjugate of the square root of 7 plus the square root of 2? The square root of 7 minus the square root of 2. On 36, do we need to multiply by the conjugate? No, we'll just rationalize the denominator like we've learned in the past. Okay, very good. All right, go ahead and finish out the worksheet. Once again, 36, you won't multiply by the conjugate. You'll just rationalize it like we've been doing in the past. But be careful when you're distributing that through on the top, on 36. Okay, be very careful. All right, finish the worksheet. Work the rest of the time.